All right, so I just told them this may very well be the worst lesson of the year. Not the worst, but could be the most challenging. So we better really be focused. All right, ready to rock and roll? Okay, so I'll talk about I'm a bum. No, not stop sharing, hide. I'm a bum with the grading. Had some other things going on, and I started grading during third period today. And it does take a long time to do the graphing grading. There's a lot of points to look at, a lot of things. It's pretty good, but I'm going to talk about some of the things that we did wrong. All right. And I'll tell you some stories about people claiming I didn't teach certain things when they were completely and totally 100% wrong. All right. But anyway, isn't this kind of weird? 1 over b times 2 pi. That just means 2 pi over b, right? Doesn't that seem confusing? And I use a lowercase b on that. One thing that people screwed up, there's a handful, and I'm only like probably a little bit more than halfway with you guys, is cotan and tan are not 2 pi over. Some people screwed that up, and therefore it affected your graph completely. It affected all the x values on your grid. So that's number one. All right, and then the word phase shift. Can everyone say phase shift? I don't know if you heard that in the computer. 20 years ago, it would have been phase shift. You really would have heard the students. The students can barely talk anymore because they're always on their phone, and human interaction is weird to them. Anyway, let's move on. Now, we're going to add this phase shift. What phase shift is just a fancy word for right, left shift. That's all it is. I've heard of phase shifting like in maybe sound waves or something like that, and that's interesting. Aren't sound waves, when you look at them on a graph, they're like sine curves, right? Or cosine curves, if you want to call that. I actually talked to you about this, AM and FM, right? Didn't I talk about that with you guys? AM is amplitude modulation. You guys know what a radio is, right? Is it? Do you ever listen to a radio? I don't know what we're at right now, like in the world that I live in. But amplitude modulation, if you know anything about AM radio, you start driving and you drive far away, your AM station sticks around longer than your FM station. Like I listened to 100.7 hard rock coming into the school, banging my head off, the wall, getting ready for teaching. But then I'm going down 355 just towards 55, and I start losing that station right away. It's because it's FM. What FM is frequency modulation. So it's a tighter frequency, but it's not as long as a wave, so it doesn't last as long. Amplitude modulation means it's a bigger wave, so its amplitude's larger. I think it's also more stretched out and it lasts longer, but that's why it's not as crisp. Anyone ever listen to AM radio, like listen to the White Sox, Bears, or something like that? It's not as crisp of a sound, but it lasts longer. Anyway, so I thought I'd cover that out because that's where I've heard like phase shift being used in real world context. I think that's why they use that word. Too much information, Mr. Samuel. Let's just tell them how to get the right answers. Okay, good factors, say it. It's actually good distributors in this case, right? You cannot assign this phase shift, and now I'm going to get into that student here in a minute, until you take out that 4. So let's get that covered first, then we'll talk about why we should already know this. What does that become? Does that become, I'll give you 2 possibilities, 2 pi or pi over 8? What's the right answer? And why is it not 2 pi? Say it again, good foilers. Good distributors. Does 4 times 2 pi equal pi over 2? Yes or no? That's the whole meaning of me saying good foilers, good factors. The check. I am infinitely sad for the student that writes a 2 pi in there. Not that they made a mistake, that they didn't check it. And that's where you don't have any common sense at all mathematically. None. And then those are the things that I'm trying to get you to stop doing. And I've mentioned that since day one. Good foilers, good factors, and this is the reason. Now, would I take a 4 and throw it back in as 4 pi over 8 equal pi over 2? Yes. I still have so many people not checking. Still. You're your own worst enemy. I don't know what else to tell you. Does sine have an amplitude? Yes or no? Yes. What is that amplitude? Is it -2 or 2? 2. What's the period? It's still that 4 value, so you wouldn't miss that 4. So that wouldn't have been wrong. Nope, that wouldn't have been wrong. What's our vertical shift? It's up 5. We've already tested that. If you don't know that, you're severely and totally. Anyone? Now this is why we should know what the vertical shift or the right left shift is. Because I've done this all year long with x squared, x cubed. I've done this with square root graphs, with absolute value graphs. I've done this with ln graphs. I've done this with exponential graphs. Let's just say x squared. We have done right left shifting and up down shifting all year long. So somebody tell me, what is the phase shift? Is it right or left? First of all, 3, 2, 1, go. Right. And what is the value? Pi over 8. So this is right pi over 8. So all you had to know was what the word phase shift meant. If you know it's right left shift, we've done this all year long. All right. Now, what's the domain of this? We know sine and cosine has an infinite domain of negative infinity to infinity. Now, it might be easier now. And by the way, all these blanks right here, these are perfect multiple choice questions. Perfect. You know, we're going to graph by hand again. I just told you it takes a long time to graph. So you have a written part. But then we throw these questions on the multiple choice. So what do I have to visualize? I go up 5, and then I go up 2, down 2. So what's the range? What's down 2 from 5? What's down 2 from 5? 3. What's up 2 from 5? And then we know that's what, sorry, that's a bracket. No bracket, you're gone. Because we know cosine does this, and so does sine. They have a high and a low point. You know, I didn't start it anyway. I'm just saying, you know, that's what it looks like, and that's the pattern. Okay, let's move on. Good factors. It's actually distributors in this point, right? Theta, then what's plus pi over 3 become? You should get an idea now. Plus what? Is it 2 pi over 3 or pi over 6? It's pi over 6 because when I throw a 2 back in there, that becomes 2 pi over 6. Only the fractionally challenged can't figure this out. What's the amplitude? Bummer. It's a half. What's the period? It's still this. And then down 6. Come on. We already did this. Down and up. I don't know why I'm circling now. I guess I have to circle them all now. It's final answers. All right. And then the phase shift. What's the phase shift, everyone? 3, 2, 1, go. Left pi over 6. I will tell you where this gets really bad, why this could be the worst. We know the domain. Bless you! We know the domain is all real numbers. I forgot what I was saying before that sneeze. It made me forget my thoughts. All right, and then we go, oh, this is weird. We go down 6, and then cosine is like sine. It's like this. So we're down 6 in the middle range. And then how far do I have to go below that? How far do I have to go below that? A half. And how far do I have to go above that? What's below negative 6? Negative 6.5. You may think that's an easy question. You can't put negative 5.5 first. It's down to negative 6.5 and up to negative 5.5. You should be able to fill these in now without graphing. You should be able to think about it. And then you could go ahead and do your values after that. I will say this is the worst. This one's not so bad. Here's why. And this is what's going to happen later. And I did this last hour and I ran out of time for the last example. We're filling up the whole time today. And you got to be able to handle it. If you can't pay attention for a full period, that's your problem. But what's half of pi over 2? What's half of pi over 2? Pi over 4. What's half of pi over 4? Pi over 8. This is a good thing when your phase shift matches a fraction of the period. Then this will be real easy to graph, and we'll do that when we hit those examples. What's half of pi? What's half of pi? Pi over 2. What's half of pi over 2? Pi over 4. Wah, wah, wah. This is the worst, hardest question of the year. When the phase shift does not match a fraction of the period. This is why you had your awesome assignment that the other two ladies made, one of the two or both, about how to work with fractions that don't quite work when you're working on an x-axis. Do you remember that yesterday? Okay. Then what you have to do is get a common denominator between those and then graph accordingly. And I think I'm going to have to wait till tomorrow when that happens. So this is going to be kind of like a day and a quarter of notes. All right. It really is. There's a lot to kind of look at there. So this is the worst question of the year. This may be the hardest thing you ever have to do. That's my opinion. I really think this year is doable. Trig, actually, I love Trig. Some people are going to do better in Trig than they did in any algebra stuff. It does happen. Really comes down to that unit circle. If you already got the unit circle down, you know what sine of 45 is right away, and all those other ones, you're probably in good shape the rest of the year. All right, what does pi over 3 become on the inside? What does that become? What does that become? I heard you. Because it's simple. That one's actually easy. Because if I throw in a 1/3, 1/3 times pi is pi over 3. All right? All right. So, okie dokie. So what's the amplitude, everyone? Nothing. You're gone. If we're jerks on a multiple choice and we ask what's the amplitude of cosecant, it doesn't exist. You're gone. But A is 7, so I got to know that. This is still 2 pi. Ooh, what's 2 pi over a third? What's 2 pi over a third? 6 pi. This is another one. Put a star by it because I did it last hour. Ugh, is that a star? I don't know what that was. Okay, this is up 2. That's easy. And then, okay, this is one that doesn't quite work out, but this would be easy to actually graph. So undo that star. Okay, this is not as bad because this is right pi. No, put that star back. I just realized it is bad. Okay, this is bad because right pi, what's half of 6 pi? 3 pi. What's half of 3 pi? 3 pi over 2. And the phase shift is right pi. This is where you're going to have to get common denominators. You're going to have to put that as like 2 pi over 2 in your mind, and then that's where your graph is going to start. All right, and that's where when the phase shift doesn't match a fraction of the period. And I'll show you what I mean when we get to the graphing. Where are these values compared to the y-axis? This is going to be a really tough grade on my part because your spacing has to be perfect. We're going to make you really, really be that. Okay, this is a tough question. What's the domain? Really tough. How does cosecant start? Does it start with an asymptote or not? I think they were nice. At the y-axis without the phase shift. What's the answer? Does it start or not start? Starts. We should know that cosecant sine, and sine is like this. Here's the y-axis, and then it would be, up to 7, down. And I know I'm ignoring the downshift. And then this is where an asymptote is, right? Right? But this got moved. Everyone tell me what? Moved what? Right. How far? Pi. So here is our domain. X such that, with our little brace, cannot equal, and then it's pi, not 0. So I know where that starts because of the right shift. And then, where is the next asymptote? How far away is the next asymptote? Is it 6 pi or what is it actually? You guys should know this, and I heard someone whisper it. What's the answer? It's half of the period, so 3 pi n. So we have a new starting point for this asymptote, so we have a new domain issue. But the asymptotes are still half a period away. And then NEZ, I just don't have the space for it anymore. But you were real nice on the test, making sure you wrote NEZ. I wouldn't have marked you wrong if you didn't. I don't know if I should admit that, but all right. So you go up 2, and then A is 7. So what's our new high value? It's not really a high value. Hopefully that's why you're not answering. What's the number in that bracket then? What's the number in this bracket to the right? So I go up 2, and that's our new dotted line, and then I have to go up 7 to start this graph. So what goes right here? You guys are killing me not saying 9 if you're not. But why is it this? Because secant, cosecant looks like this. So there's a gap in the middle of the range. So I'm saying these values are the 9s. And then what are these values for y? What are those values? I don't know if I heard anyone say it yet. What's up 2, but then you have to go down 7 from 2. I don't know. You guys heard, like, I don't know if they're speaking English. They're drooling when they're talking. I don't know what. I can barely hear them. Okay. -5 was the answer. Okay. Right? We all good? Worst one right there. That one's tough. I think both of these are equally tough to graph. We're not yet, but we will run into one that is like that. What's the amplitude of this one? Here, I'll write this in here to trick you. What's the amplitude? NA. One is our values, though. 1 and -1 are key ones. What's the period? It's just pi over 1. Pi. Of the 10 or so graphs that I've graphed or graded so far, 2 or 3 people didn't know that. You're gone. It's pure memorization. NA again, and then this is pi over 4 to the right. I can almost sketch this one real quick and tell you why this one's easy. Not sketch it, but, well, I am now. Because, unfortunately, what does tan start as? Tan is the asymptote at the y-axis, or what do we have at the y-axis? A point, right? So then, what did I have to do to get this period or this asymptote? I had to take half of this. So wouldn't you agree that this would be the graph of this, pi over 2? And then what's half of pi over 2? And then these are negative pi over 2 and pi over 4 negative. But then what I'm getting at is this. Look at the phase shift. Ah, this is a good one. This is not the hardest thing I have to do all year. So the asymptote should have been here, but now they're moved pi over 4. I'm sorry, I didn't put this right. So there's where the asymptote is. This is easy. 1 pi over 4, 2 pi over 4, 3 pi over 4. So when the phase shift is a portion of the period, we're good. This is going to be easy to graph. It's not going to be easy when it's not. This is flipped upside down. So that this is an easy one. This is not the hardest thing that you've had to do all year long. But why did I just do all that? Because I'm on a domain now. And what's the domain? Not the asymptotes. So x cannot equal, pick one. You could either do negative pi over 4, or you could do 3 pi over 4. It doesn't matter. Okay, so I still felt compelled that I had to sketch this real quick to legitimately get the domain. Now, how far is each asymptote away in a tan and a cotan? In general, it is the, starts with a P, period, pi n. Got it? And then domain is, or range is easy. It's always all real numbers no matter. Are you going to be okay? Looks like you're about to pass out. You're rolling your neck back and forth saying, oh, yeah. You just like, I still have half the class left. Oh. Good factorers, good what? Distributors. What is x plus, what does plus become? Plus what? Pi over 2. And then this is what I did last hour. So, okay, that's 3 cosine that. So I don't have to write all the things, but I do have to find the period, which is 2 pi over pi, or 2 pi over 2, which is pi. Ah, now that life is great on this. Because what I did over here was I did a little pre-planning. I did pi here, then I took half of pi. I was thinking about, like, if I had to graph this without a phase shift, these are the values I would need. 1 pi over 4, 2 pi over 4, 3 pi over 4. So I'm getting a plan. And then I noticed that this is plus pi over 2. So it's pi over 2 to the left, which equals a portion of my period. It represents half of a period. I'm good. This is far from the hardest thing I've ever done in my life. No way. I'm going normal. I'm putting my axes here. And then I'm going to go ahead and mark this up. I like going by 2s just for space purposes. And I am going to mark this. I'm going to mark this as pi. I'm going to graph it in a different color. Half of pi is pi over 2. Half of pi is pi over 4. And I'm telling you where you're going to get marked wrong, and some people can't find this third value. So it's 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4. All this is all of these are pi over 4 away from each other. So I just keep adding pi over 4 until I get the third one. Some people can't do that. I can't help you. I can't help you with your grade school fraction work. All right. Then next one, but I am helping you because I am covering it still. But I am telling you in the future when you're on your own, I can't help you figuring that out anymore. That is a grade school concept just with pi in the numerator. We're going to cut and paste, and then we're going to go ahead. Just wanted to look at that again. That's 3 pi over 4. Okay, so then I'm going to go pi over 2 to the left, and notice I am right there. I didn't have to do any extra work. The period matches nicely with the phase shift. And this is where I start. And what do I start? It's a cosine kid. All right, last hour did make me angry. Let me get this here. Let me get my 1, 2, 3, because nobody answers any questions. It's not like it used to be. It's the droning, I think, and the looking at the phones and lack of community. I don't know what it is. Here he is complaining again. But what does cosine start as? Does it start at 3, 0, or -3 with what I have over here? 3, 2, 1, go, class. 3. So I'm going to start a cosine kid, but left. So I'm going to graph the cosine. Then what's pi over 4 negative? 0, 3, or -3? 0. What's 0? And be careful. Here's the worst thing that happens. It did not. 0 sometimes is not a critical value. It is not a critical value when your phase shift doesn't match a portion of the period. And that's where students screw up as well. But this is okay because it is 1/4 pi away from pi over 4. So be careful of that. I just thought about that. That's 0. Then this is back or -3. That's 0, and then that's 3. And then there I go. I got a hiya cosine kid. I had to check. Was this a secant graph? No, it wasn't. So I had to stop myself for a second. And then honestly, you know what you could do? You could do this, and guess how many periods you have? How many periods do you have? Well, this is a full period. This is a half period, and this is a half period. What does that equal? How many periods? 2. But what I did last hour was just what I was thinking conventionally here. 1 pi over 4, 2 pi, 3 pi over 4 pi over 4, 5 pi over 4. I did this last hour. 6 pi over 4. So you could do what I said there. You could go backwards and forwards, half period, and you'd have 2 periods. Or continue the flow to the right. Oh. So I would call that not real hard. That's just a little bit of a stretch, what you already know. A little bit. I think we're in trouble now. I don't remember this. I'm not doing my math in my head real quick. By the way, when I pull out a 3, what is, whoa! We're in a lot of trouble. What did I literally have to take out? Not a 3, but a what? -3. So that pi doesn't go first. Who's supposed to go first? X. You've never done that before. Liar! We've done that with x squareds, x cubes, ln's, exponentials. What else have we done this year? Okay, let's finish this off. What does 3 pi become? Pi. And you know it is minus pi, right? Right? This is really weird. Okay, but here's number 1. What does this negative on the inside of the function mean? What does that mean? What does that mean? Okay, I'm going to give you a 50-50. Is it X or Y? 3, 2, 1, go. Pick one. No one said anything. You at least said something. Thank you. But it was wrong. All right, so what was the other one? It's a Y axis. Anyone? Y axis. Anyone? Reflection. So this is why this is, now we're adding this. What? We're adding this now? This is new. Wrong. You've had y-axis reflections all year long. Okay, don't shake your head. All right, here we go. Now, before the phase shifting, let's ignore this for a second. Wouldn't you agree that this is what a cosecant looks like? That's just a real, I should have drawn it larger, right? Right? Okay, let's start over. That's really terrible. Ooh, so mean. You know, I'm in a bad mood because of the IDs. Just the kids. I'm so cool, I don't wear my ID. All right. Oh, wait, let's do this. Down, right? And then up, right? Wouldn't you agree that if I y-axis reflect this, this is over here now, the green? Y-axis reflect that, that's now the green, right? Don't you agree that a y-axis reflection suspiciously looks like a what else? Can you verbalize it? And x-axis. Teaching so it just used to be so different. That's because there's an identity that says this. Cosecant of negative x is equal to the opposite of the cosecant of positive x. You're going to have to know that in the future. You know what else you're going to have to know? Oh, here we go. I didn't do this last hour. What does that mean cosecant is? Oh, you won't get that. What was that noise, by the way? What's that noise called? That's symmetry. What kind of symmetry is that? Origin. What does origin symmetry mean? The function is, it also starts with an O. There's 3 letters. So if there's origin symmetry, the function is O. There's only 2 more letters. Here, let's play Wheel of Fortune. That's a D. Okay, what is old? I think it's old. No. What is it actually? Ord? No, ort. There's an ort cloud. No, oh, it's odd. Oh, that's the word. It's odd. It's because no one's saying anything. This is why we have to do these things. Okay, this one is weird. So what's the period? The period is 2 pi. Is it over -3? No. We've handled what the negative mean. And we ultimately found that a y-axis reflection for this particular graph is just like an x-axis reflection. It really doesn't do much. Ooh, I wanted to get into secant. A y-axis reflection for secant does nothing because the u is right on the y-axis and you just flip over the y-axis, right? That's because secant is even and has y-axis symmetry. So anyway, some things you'll have to know in the past. And then, you know what? Here's what's weird. The period's 2 pi over 3, but the phase shift equals pi, which is 3 pi over 3, right? This is kind of what you had to do yesterday. What's weird about this? And the answer to that is, because you won't answer anyway, the phase shift is, Ferris, are you listening? The phase shift is larger than the what? Period. So this phase shift skips like a period and then goes a little bit farther. It starts at way right on the x-axis. So here's what I've always told my students. Let's wait. So you know what I'm going to do? I'm going to put my x-axis right here. I did not do that last hour and my graph went off the grid. That was number 1. Number 2, I can get this phase shift kind of to be matching with the period because of like denominators, your yesterday assignment. So I'm going to go with it, and then I'm going to tell you my thing at the end that I actually told my 4th hour in the beginning, and they weren't too impressed with it. So I'm going to go ahead and do 2 pi over 3. I go by 2s. 2, 3, 4. Here's 2 pi over 3. Half of 2 pi over 3 is pi over 3. Half of pi over 3 is pi over 6. This is like level 2. This was level 1. This was not hard. This is a little bit weird because of that thing I just covered. 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. I can't cover that anymore. You got to know how to add pi over 6 to itself, the quarter value. Okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This is why I knew I was okay. And then finally 6 pi over 6, which is where I'm going to start this graph. Yikes. But you should already realize something. I could have started it here. Because what does this represent in this area? Another, starts with this letter, another period. So I am going to cover this real quick. When the phase shift is larger than the period, you can take the phase shift and subtract the period out of it and then start here instead, which is exactly what I just identified. But you know what? I'm going to keep going because I know not everyone's going to understand that. I'm going to start here, which requires I have to keep going. 1, 2, 3, 4. So what are we on over sixes? 6 pi over 6, 7 pi over 6, 8 pi over 6. If it helps you, write them off to the side and then reduce. You know what? I guess now I can't mark you wrong for reducing or not reducing. 9 pi over 6 because AP doesn't care about reduction. 3 pi over 2. Some of you didn't reduce, and I did not mark you wrong. You really should, though, but I don't know. Old school me really wants to mark 10 pi over 6, which is 5 pi over 3. Old school me really does want to mark you. All right? And we're going to start here. And then what is cosecant? What do we graph for cosecant? Who do we graph? Sine or cosine? Sine. So it's up 2, down 2. There is no up-down shift, so I'm okay with that. And then I'm not asking you anymore. Sine starts at 0, then the high point. Wrong! What was all this that I covered? What happens to this graph? It gets flipped over the y-axis, which is equal to flipping over the x-axis. That's why I went through all of that. So they put a lot of tough stuff in there. And then this is where an asymptote is. This is where an asymptote is. This is where an asymptote is. And then let's go back to our, here's the y-axis reflection, which is equal to an x-axis reflection. That's why I know what I'm doing from this over here. And now it's easy. This is why 1, 2, 3, 4. Oh, okay. Now I actually get a little better idea of that. That's pi over 3. I know that looks like a 7 there. Because then it's really the continuation of this. High point, 0, low point, 0, asymptotes. Now do you see why they give you a blank grid to work with? You got to do a little pre-planning to know how big that phase shift is comparative to your period. And then you have to, and the distance you are from the y-axis must be the same for everyone. Must have quarter values of the period mixed in. Must, or else you're doomed. And I will get you with the red pen. Okay? He's so mean, but I just got to tell them how they're going to be graded. They must know. They must know. They must. Okay, what happens when I take out a 2? What does pi over 2 become? What does pi over 2 become? Pi over 4. Okay, we got to get past that. Oh, and it's flipped. Okay, fine. And it's cotan. The right, left. Okay, you know what the period is? The period is pi over 2. Is that good or bad for a phase shift of pi over 4? Good or bad? What's half of pi over 2? Is this good or bad? Good. This is level 1. This is level 1. This is not hard. This is barely stretching your brain. Barely. Okay, so I'm going to go right to the middle. I'm going to go here. Unfortunately, it's the last one. I think that ends up being the worst of them all. And I think I'm going to save it for tomorrow. This is going to be 1 day and a quarter of notes. I wish this was a full day, and I'd have 11 more minutes. Okay, so how does cotan graph? Cotan starts with an asymptote and ends with an asymptote. You know what? I know my phase shift is good, so I'm going to go ahead and do that. I'm just going to go ahead and mark this as if there's no phase shift. Half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. I can't help you anymore. My verbiage should help you. All right, now what's supposed to happen is I have an asymptote here, but this is moved pi, I should put period, pi over 4 left. Okay, good. 1 notch, 2 notch. So there's where I'm starting, and I'm going to put that up in my, and this is why I know I'm good. All my spaces on my x-axis are kosher. And actually, this is good. 0 is going to be part of it because that's pi over 8 away as well. The worst. That's like, I'm going to jump to level 5 when we get to a tough question. Skipping level 2 completely, 3 and 4, when that doesn't happen. And how does cotan start? We're running out of time. If you don't know this, you're severely and totally behind. Cotan starts with an asymptote. So this is where I'm starting because of the shift. Now it gets real bad when it's tangent. Tangent starts at 0, 0, and then this is where the asymptote would be. All right? And then it was supposed to end here, but now it's over here. That's where a period is. And then what's cotan supposed to do? Increase or decrease? It's supposed to decrease, but what is it doing now? What's it doing now? What's it doing now? It's increasing. So half, we'll go by ones this way. We'll mark 1 here and here, -1. Then it's half values. That's what the half does when it comes in. Rushing at the end. All right, 3. Okay, so 1 pi over 2 pi, 3 pi, 4 pi over 8, 5 pi over 8. What's he doing now? Another period. 6 pi over 8, 6 pi over 8. My brain's a little overloaded. That's 3 pi over 4. So I like writing the work off to the side and then reducing. And then that's easy. Got repeat and repeat. Boink, boink, boink. All right, and then it's the values. Make sure I can see those values. That's why I chose colors there. Okay, I'm going to stop there. Ooh, that's a lot. Checking IDs outside. 5 out of every 20 students don't wear them because they're cool. And then I have to come in here and teach. I don't know how to stop this. Where's it at? Where's the thing? Oh, there it is. There's my face.